So let's see if you can kind of put this into perspective. The area of a circle increases at a rate of 20 square inches per minute. Okay? At what rate is the radius increasing when the radius is 5 inches? Sounds like a challenging problem, correct? We're going to make it rather easy. What you have to understand in the problem is what is changing. Okay? So I like to take word problems and I like to divide them up into 4 sections. Okay? And I like to do that because it helps me organize my thoughts. And in the first box is where I model the problem. And then in this box over here, there's always some type of relationship that I express. And by the way, this is for basically every word problem I do. It doesn't matter if it's related rates or whatnot. There's usually always some type of equation here that I deal with. And then the last one is where I actually solve and come up with the solution. So that's kind of my goal. And by the way, this is a very quick summary of what this entire, so this was my last paper I wrote. So as part of so we'll show you. All right, let's model the problem. We have a circle, and it's getting bigger. So you tell me the things that are changing if the circle is getting bigger. The circumference is changing, the radius is changing, the area is changing, the diameter is changing. Everybody agreed? There's one more thing that's changing that's not part of the circle. It's something that connects all problems together. In fact, as we say related, what's that? Thought I heard it. Related rates, all rates are related back to generally one thing. It's something that is always changing around us. It changed this weekend. We got an extra hour of it. Time. All right, way to go. Feeling positive today. I like it. Okay, here we go. Time is changing. Okay? And so we're going to use that time piece to our advantage here in a little bit. So the first thing I'm going to do is I'm going to come up with a formula for the area of a circle. What is the formula for area of a circle? Area is equal to pi r squared. Okay? And over here, I'm going to write down a few things that I know. Okay? What am I given in the problem? The rate of the area increase, right? So in other words, the area is not 20, but rather the derivative of the area is 20. Everybody see that? What else are you given? The current radius is 5, right? So when the current radius is 5 and the area is increasing at a rate of 20, at what rate is the radius increasing is our question, okay? Now, this formula right here, does it have a prime in it? No. How do you think we'll come up with an a prime? We're going to take the derivative of it. Now, just to be clear, because I want everybody to understand this operation, this comes back to our implicit differentiation piece. If we had, say, 4x squared plus 2 is equal to 3y, take that derivative. What's the derivative of 4x squared? 8x plus 0 is equal to? Now, please just remember that when you took that derivative, when you took that derivative you took the derivative with respect to x. And because of that, when you took the derivative with respect to x, we didn't have to attach an x prime. But we did have to attach a y prime, agreed? So that's very, very, very important to understand. Because in order to solve this, we take the derivative with respect to time of area equals pi r squared. Do you have a t variable in this problem? So therefore, anything you take the derivative of, you'll have to attach a y prime or an r prime or an a prime. Okay. So what is the derivative of a? 1a prime, right? If you said the derivative, you say 1, and then we attach an a prime. Anybody want to guess what the derivative of pi r squared is? 2 pi r, and then you have to attach an r prime. We okay with that step? All right, so this is my derivative, okay? That's what I generally do in this box. I wrote equation. This is the equation I'm going to end up using. And now let's go back to our important information. A prime is 20. So notice if I have A prime is equal to 2 pi r r prime, I plug in 20 for A prime, 2 pi. I know the current radius, it's 5. And I'm trying to solve for r prime. Will I now be able to solve for r prime? Yeah, not a big deal at all, is it? So I will go ahead and take out my handy-dandy calculator. And I'm going to take 20. (10 pi r prime). If I divide both sides by 10 pi, notice I get 2 over pi is equal to r prime. Now, if you want to come up with a decimal, 2 divided by pi, you can. You get 0.64. And I should attach a label to it. 0.64. And now let's think about the label. What did we solve for? What does the 0.64 represent? The rate at which the radius is changing, right? Radius, is that a one-dimensional measure? Is that a two-dimensional measure? Is that a three-dimensional measure? Okay, let's help everybody understand that, okay? If I have this shape, is this a two-dimensional figure, a one-dimensional figure, or a three-dimensional figure? This is 3, right? Has 3 dimensions. So if we're measuring area, area is a 2-dimension. If we measure volume, volume is a 3-dimension. If you measure length of something, then that's a 1-dimension. So length of the radius is a 1-dimensional piece. See that? Whereas if it's area, it would be 2-dimensional. So your label would be a squared, like inches squared. If it was volume, it would be like inches cubed. Whereas this would just be inches. You see the difference there? So when we measure radius, we're just measuring a single dimension. So we would just say 0.64, and then what's our label in? Inches. So you could leave it as 2 over pi inches. That would be fine as well. Oh, I'm sorry. It's a rate. So this is a rate. Inches per what? Minute. We'll do a very, very similar example right here. It says a basketball is being filled with air at a rate of 1 cubic centimeter per second. At what rate is the radius increasing when the radius is 12? Does this sound familiar? What's the difference in this type of problem? Centimeters cubed. So are we talking about length or area or volume? Talking about volume. What shape do we have? A sphere. I'm not very good at drawing a sphere, but I'll do my best. I draw a circle, and then I kind of draw that to help people understand three-dimensional. Tay wants to shoot it. Very good. Okay, so we agree that the volume's changing, the surface area is changing, the radius, all that's changing, right? But what other thing is changing as well? Time. And as you can see, per second, time is what kind of bonds us all together. It's a really good thing. Now, you're trying to remember the formula for volume of the sphere, aren't you? And I'll give these two formulas for you. They'll be important. Volume of a sphere is equal to 4/3 pi r cubed. And I'll give you another formula. The surface area of a cube. Did I say cube? Sorry. The volume of a sphere is 4/3 pi r cubed. The surface area of a cube. So, like if you were to try to take a basketball and wrap it in a... I did. If you're going to try to take a basketball, a sphere, and wrap it in, like wrapping paper, you would need 4 pi r squared. For some crazy reason, the surface area ends up being exactly 4 times the area, which is really weird. Okay, let's write down some things that we know. What are you given in this problem? What is 1? Is 1 the volume or the volume prime? Volume prime. Because it's a rate, it's per second. What else do you know in this problem? The radius is 12. And what's it asking us to find? The rate the radius is increasing. So that means we're looking for r prime. So I'm just going to write r prime question mark. That's what we're looking for, trying to find it. Okay. All right. So looks like I should take the derivative with respect to time of volume equals 4/3 pi r cubed. So what's the derivative of volume? Volume prime. Anybody? 4/3 pi r cubed. 4 pi r squared. R prime. You okay? Okay, V prime, I put in 1. It's equal to 4 pi times, what do you get if you square R? 144 R prime. Just going to do a little bit of work here. 4 times 144, it's 576. So we've got 1 over 576 pi is equal to R prime. And just so that we kind of avoid making mistakes, watch how I get a different answer here. If you take 1 divided by 576 and you attach pi, it's only going to take 1 and divide it by 576, then it's going to multiply by pi. Everybody understand you have to put that in parentheses? So I'll go back here and I'll put a parentheses 576 pi. Now it's going to do both. So I'll go ahead and come up with a decimal answer here, and we get that. So how do I write that? A little scientific notation review. Anybody? 5.5. That's times 10 to the negative 4th, right? So I will actually move the decimal point 1, 2, 3, 4. So it looks like it's going to have 3 zeros, right? So if you did want to express it as a decimal, it would be 0.000, 55. And what's our measurement in? What are we measuring right now? Yeah, radius. So that's going to be centimeters per second. So that's a pretty small value, isn't it? So when you're filling up the basketball, are you really going to be able to tell that the radius is changing? No, you're not. That's going to be pretty tough to tell. But if you look at the volume is increasing at 1 cubic centimeter. So you might notice a little change in your overall size, but not the actual ball. Okay, pause. Please find example 4 in your notes. Example 4 in your notes. No, circumference is 2 pi r. Circumference is distance around a circle. 2 pi, or surface area would be the area that covers a three-dimensional figure.
2 pi r?
Yes, circumference is 2 pi r. I'm gonna pretend like you knew that, okay? Because that's one you want to know. Okay.
Hey, what's wrong with you, man?
All right. It says the volume of a ball is increasing at a rate of 10 cubic centimeters per second. At what rate is the diameter increasing when the volume is 100 cubic centimeters, period? So the volume is 100 cubic centimeters. Who can tell me what makes this problem different than the problems we've currently looked at?
By diameter.
Yes, we're looking at diameter. Okay? And second of all, it says when the volume is 100 cubic centimeters, it doesn't tell us exactly what the diameter is at that specific time, nor the radius. Fortunately, you're extremely intelligent people. You're not going to have any problem with this. We ready? I have a sphere. What is my formula for the volume of a sphere? Excellent. Volume is equal to 4/3 pi r cubed. Let's write down a few things that we know in this problem. What do you know? V prime is 10. What else do I know? I know the volume is 100. It says, at what rate is the diameter increasing when the volume is 100 cubic centimeters? Are we okay with that right now? Okay, now, what are we looking for in the problem? The rate of the diameter, agreed? So we're looking for d prime. Now, get ready because we're going to make your mind explode here, okay? If I take this derivative, will I come up with a d prime? No. You don't have a d variable at all, do we?
No.
So we've got to change that. Can somebody tell me the relationship between radius and diameter? Everybody agree radius is 1/2 of the diameter? So look at what we can do. You are always used to seeing these formulas written in terms of radius. You could write them in terms of many different variables. What I'm going to do is I'm going to take this and substitute it right in for r. Yep, because it says r is equal to. And when I do that, I get volume is equal to 4/3 pi times the quantity 1/2 d cubed. Some people at this point decide to take the derivative. Don't, because you would have to use the chain rule. I don't want to use a chain rule, so let's just cube this. Volume is equal to 4/3 pi. What is 1/2 cubed? 1/8. And then I have d cubed. So, can somebody give me this formula with reducing those fractions? Well, we're going to have 4 on top, right? You have 24 on bottom, which will make 1/6. So, in other words, you have volume is equal to pi/6 d cubed. Well, it's pi/1. So I have a new formula, and it involves the diameter. We'll do it one more time here. So I've got 4/3 times pi/1 times 1/8. If we look at those fractions, you get 4 pi on top. On bottom, you get 24. What's 4, whoops, sorry. What is 4 over 24 reduced to? 1 over 6, so I've got pi over 6. All right, so that's my formula. So what I'm happy about is that I now have a formula that involves diameter. Let's take the derivative with respect to time. What's the derivative with respect to time of v? V prime. What's the derivative of pi over 6 d cubed? 3 drops in front to get 3 pi over 6, which is pi over 2. Good. D squared d prime. So v prime is equal to pi over 2 d squared d prime. So what do I put in for v prime? Good. What do I put in for d? I don't have the current diameter, do I? I have the current volume. If I know the volume is 100, could you find the current diameter? So let's do that. So I have 100 is equal to pi over 6 times d cubed. That's going to allow us to find the diameter and plug it in there. How would you solve that equation? How would I get rid of the pi over 6? Divide by pi over 6 or multiply by 6 over pi. So if you multiply by 6 over pi, I'll get 600 over pi is equal to d cubed. Now what do you do to both sides? Take the cubed root. So I'll do that on my calculator. I'm going to take 600 and divide it by pi. That's not my answer. I have to take the cubed root of it, right? Now, I know that you guys are used to using cubed root here, right? Can I show you how I take cubed root? Because I don't like to go in the math menu all the time. Here's how I take the cubed root. I take that and I raise it to, cubed root is the same as the 1/3 power, right? Yep, square root is 1/2 power, 4th root is 1/4 power, so I just go to 1/3 power. I get 5.76. So the current diameter is 5.76. Is that enough information now to solve my problem? Yeah. Everybody agree that it's definitely gonna be kind of a nasty looking decimal. So let's just kind of figure out what decimal we get on the right hand side here. I've got pi divided by 2 times 5.76, and I'm going to square that. And I get 52.12. So 10 is equal to 52.12 d prime. And now I take 10 and I divide it by that answer, and I get 0.19. So d prime is equal to 0.19. What's our measurement? Centimeters per second. So, when you have to substitute something else in, that can make it very difficult. However, we're going to deal with the lower side of the difficult level of those problems. What I would currently like you to do is look at your sheet right here. I told you to focus on problems 1 through 6. It would be great, it would be absolutely great if you could also do problems 9 and 10. 9 and, no, I'm sorry, forget about 9. Try 10. Problem 10. Try problem 10. And then tomorrow we will finish off with our last couple related rates problems. I will give you a study guide, and you can kind of be on your way. If you'd like a study guide today, just stop by my room by the end of school, and I'll have it printed off for you.